We're going to talk about water bodies inside of Unity because it's going to be really important to understand how water bodies are presented, how they're created, and what you need to do to make them look right. It's one of the trickier things to do is to get water to look correctly. So let's talk about these a little bit. So water bodies inside of Unity will consist of three elements. You might be asking, why do we need to know this stuff now? Aren't we in Inkscape? Yes, we are, but we need to do some things with terrain and our splines before they go to Blender, because Blender is going to create these elements and then we're going to export them into Unity, and then Unity is going to present them. But we need to do them correctly inside of Inkscape in our terrain and then Blender, and subsequently they'll look good in Unity. So water bodies will consist of three elements. The first one is the water edge. So think of this as, where your actual water, your rippling water, hits the bank or land. That is your water edge. So think of that as kind of like the rocky sides of your lake, where your normal land, which is out to the sides, meets your rippling water. That's your water edge. Then you have your water base. The water base is the bottom of your water. So whether it's the rocky bottom of a stream, whether it's the mucky bottom of a pond, but think of that as the stuff that is kind of underneath the water, all the way at the bottom where the water kind of stops and the land starts, but underneath, okay, way underneath. And that could be, depending how deep your water is, that could be really far down there. And then you have your water plane. The water plane is the top, is the water itself, and that's the plane that sits on top. And it's what really we're trying to get is that water plane look, that rippling look, and it is completely flat because it's water. It fills whatever space it has, so it is completely flat. So if we've got these three things, okay, and your water plane should be on top of your water base, right? If your terrain is flat, those elements are going to clash because your water plane and your water base are going to be basically flat up against each other. And that's not going to look like. We're going to get some Z fighting in there. Um, but if you lower your terrain, it'll allow that base and edge to go lower and sit underneath your water plane. So now that base will be underneath the plane, and your edge and your water plane will just touch each other perfectly. So let's explain this. Let me try to explain this a little bit differently, and it might help with a diagram here. So I'm going to attempt something new here. So let's take a cross-sectional view of our terrain. And if I draw this out, let's say, and if this is our terrain, we're looking at it from the side. And when I say terrain, I mean like our LiDAR data, our height map, okay? And what I've drawn here is, to the best of my ability, is this would be like your normal land over here, and maybe this is a green or a fairway. And again, we have land over here as well. And this here is ultimately going to be our water body. Now, this would be like the embankment here. And normally in real life, the water body would look more like this. Let me change the color here just a tad. The water body would look like this. At least the terrain would be, right? If I were to empty this out and take all the water out, it would probably look something more like that, because our water, and sorry, I don't have blue up here readily available, so it's going to have to be green. It's going to be an algae-based pond. And our water would be kind of up here, right? And then this would be here, our edge, this embankment right here where our water meets the side. This would be our water's edge. And then this area down here, I'm going to try drawing it. You see me scribbling. This is our water base. However, when we imported our terrain, our LiDAR data, and that plane flew over the top here and it's shooting down, getting that data, it just found this flat area up here, which was our water plane. So when we import our LiDAR, our terrain, into our project, we essentially have more or less a flat terrain. So what we have to do is go into our terrain and dig this out so that we can get separation between our water plane here, our water base, and that so our water edge and our water base aren't just flat. Because if we don't get this separation and we've got our water plane again here, and our water base is also here because we didn't dig out a terrain, we're going to get some weird Z fighting. So the idea here is we're going to do now in the next lesson, I'm just going to show you how to dig these out. It's not going to be much different than bunkers, right? Same concept as far as the digging goes. One additional note regarding this is that we don't need to dig out very much. So this space here can be minimal. I usually do a meter or two. Where you want to make this maybe perhaps deeper is if you decide, and this is an advanced topic, probably won't be covered here, but it will be on Discord, is if you want to put like a wall or a bulkhead along the sides, like a retaining wall. So if you want to do that, then yeah, you might need to dig out a little bit further so that bulkhead can fit in here really nice. But for the purposes of today, we're probably going to dig this down a meter or two just to get a little bit of separation in this area.